In machine learning, we focus on learning from data which is given by user. So let me show you first the fundamental of this, then before going to the detail. So first and foremost thing, in a normal programming case, so we generally have a program, and based on program we have some inputs, and parallelly we are getting some outputs. So in any program we are having some input, and based on input we process our program, we get some output. So we take an example of getting sum of two numbers. So there we are having so we are taking two numbers from user, n1 and n2. And in program we are writing like this, n1 plus n2. That's my processing which I'm doing, and I'm getting some output in the form of result. That's a normal programming language is doing. But in machine learning we are saying we are having a slightly different ecosystem altogether. We are saying in a programming system, input as well as output. So I say input I am saying, and output I am having. Now based on two parameters, input and output, I have to implement some program which give me output as a function, program to solve the future task. For example, suppose I am having some inputs, like I am having sales data with me, and output I am expecting the output is my profit. So vice versa, you can say we are having marketing expense as well as sales also. We have both the option which can take. Let me take the marketing expense versus sales. So I'll say I'm having one term in marketing expense as input, and I am saying sales is my output. So here I am saying, so I'll be taking this marketing expense as an input and sales as an output. So suppose I am taking example of program which is linear regression. So this machine learning algorithm will do what? It will try to get the calculation of slope, intercept and other related calculations to help me to take a linear equation, which is nothing but sales as a slope into marketing. I am using short abbreviations, and intercept. That's a case which I am getting from this machine learning. So we can notice one thing, that in normal programming scenario, if you take any other language, so we are having input and we had program, then we process it. But in the case of machine learning per se, we are having input output. Based on both, this machine learning algorithm will learn from your data part, and that give me a functionality, or give me a function which I can use for future predictions. That's a perspective which we have to take care while understanding the concept of machine learning. That's a part of machine learning. So in machine learning, we are saying we are primarily having two subcategories. I'll say machine learning can be divided into two parts. So one we say is a supervised learning. Other one we are saying unsupervised learning. So in the case of supervised, we are saying we are having both the elements with us. It means input and output elements are available to process the ML algorithm. But in the case of unsupervised, we are having only input elements for process the ML algo. There's a major difference that in supervised we are having output which we can take for reference for calculating my future output, but in unsupervised we are not having output parameter with us. We need to create some other ecosystem to get the output parameter first before going to the prediction part. So we'll go with this unsupervised later. So in supervised we are in two segments altogether. So we are in first we are having regression part. So where we are saying we are expecting, we are getting trends of data and output element would be a value, or you can say continuous value first. Next I say we do have classification. Here we say it helps me to get the grouping of data, and output element would be in form of a class. For example, we are expecting pass, fail, accept, reject, or any classification which is not a form of value, which means we are not getting a like a salary prediction or sales prediction, marketing expense predictions. Anything other than the value part we are getting in the form of class or group. We are using classification algorithms. So classification case always be used where you are having outcome as a class. Whereas in regression we are saying outcome would be in a form of value. That's the basic difference available. In unsupervised we are having concept of clustering. Here we are creating groups based on the data availability so based on density and spread of data we are seeing we are getting clustering. So let me put small icons of plotting. So in this case suppose we are getting data like this. So in regression we are getting a straight line, whereas in classification case we try to let me take normal. Here we try to divide our data values based on their group type. Say on right side I am putting red dots, and on left side I am having black dots. So in classification we are getting a grouping. So one group is this, other group is this. In the case of regression we are getting trend line. So but in the case of clustering, so what we are doing, let me make this line charts. Yes. So I am putting some data likewise, say so I am having same data with me. I am putting some dots there, and parallelly I am having some dots here. So there is no classification available currently. All dots are black in nature and having the same size. Clustering will do what? It helps me to make a groups. So that I can name my classes and I can use this clustered data in my supervised learning. So once you get a clustering, you are having one name against the group. So once data has been grouped, so we can use classification case for future predictions. That's a primary notifications available for broader classification. So depending on requirement, we choose the supervised, unsupervised, and regression, classification, clustering algorithms. Let me go back to the slides. So in machine learning, we are saying in daily life we are seeing most of the cases which are directly related to machine learning only. Say this is a Snapchat, this is Xbox game, Netflix and YouTube. The common thing in all is they are not made for single user, they are made for generic, and based on the user preference, based on data given by user, this all ecosystem will be get designed and react based on users input. So in case of definition per se, we say it's an algorithm that can learn from data without relying on the standard program practice. So we are not saying that this is the summation function and you have to do the summation. It has been designed in such a way that it take data, input data, output data in such a way that he can create a functionality which can use for future predictions. So if you have data, if you change data, then your linear equation will be get changed. It's not like that you are in standard linear regression as an output you always be getting, but linear regression output will always be depending on the input part which you are given and output part which you are given in an algorithm. Based on input and output, both case you are getting in an output equation. So we are saying without relying on the standard program practice, we are not writing specifically for data. As and when data is received, we design our algorithm accordingly. The purpose of ML generally classified in three parts. One, push workload to the self-sufficient machines, pattern recognition, and analysis of data. More or less, all three things are widely used for to support the ML uses. So as I discussed earlier, supervised and unsupervised. Supervised means we do have data with us from where I can learn, but in the unsupervised, I don't have data to on the basis of learn. I need to get for fresh search of my clustering and other things. After getting clustering, then only I can say this is my output.